Okay, I'm going to continue this problem by performing those row operations on row 3 and row 4. On the next slide, the first two rows will not change. So my first row stays 1, 1, 1, 1, 4. My second row stays 0, 1, negative 2, negative 1, 0. And performing the row operation on row 3, we will do negative 3 times 0 plus 0 is 0. Negative 3 times 1 plus 3 creates the 0 I want. Negative 3 times negative 2 plus 4 is 10. Negative 3 times negative 1 plus 2 is 5. And negative 3 times 0 plus 10 is 10. For row 4, we'll do 4 times 0 plus 0 stays 0. 4 times 1 plus negative 4 creates the 0 I want. 4 times negative 2 plus negative 1 is negative 9. 4 times negative 1 plus negative 4 is negative 8. And 4 times 0 plus negative 9 is negative 9. So this is my resulting matrix now. And we can see we have our first one with the zeros below it. We have our second one with the zeros below it. Our next goal is to turn this 10 into a 1. So to create the 1, I'm going to multiply that row, row 3, by the reciprocal of 10, so 1/10. So our new row 3 will equal 1/10 times our old row 3. Technically, division, we can't say we're dividing row 3 by 10 because division is not defined for matrices. Okay, so my first row is staying the same, 1, 1, 1, 1, 4. My second row is staying the same, 0, 1, negative 2, negative 1, 0. My fourth row is staying the same, 0, 0, negative 9, negative 8, negative 9. And my new row 3 will be 1/10 times 0, which is 0. 1/10 times 0, which is 0 as well. 1/10 times 10 creates the 1 that we want. 1/10 times 5 is 1/2. And 1/10 times 10 is 1. So this is our resulting matrix. And we can see that we have our 1, 0, 0, 0, our 1, 0, 0, our 1 in the third row, third column, and now our next goal is to turn this negative 9 into a 0. So to make the 0, we take the opposite of the number we want to turn into a 0. So the opposite of negative 9 is 9. Multiply it by the row that has the 1 that we just created, so row 3. And add it to our original row 4. So our new row 4 equals 9 times row 3 plus our old row 4. And we will show this on the next slide. Here, our first row stays the same, 1, 1, 1, 1, 4. Our second row stays the same, 0, 1, negative 2, negative 1, 0. Our third row stays the same, 0, 0, 1, 1/2, 1. And for our fourth row, using our rule, we'll do 9 times 0 plus 0 is 0. 9 times 0 plus 0 is 0. 9 times 1 plus negative 9 creates the 0 that we want. 9 times 1/2 minus 8 is negative 7/2. 9 times 1 plus negative 9 is 0. This is our resulting matrix. We can see we have our 1, 0, 0, 0, our 1 in the second row, second column, and 0 is below it. Our 1 in the third row, third column, and our 0 below it. So our last goal is to turn this negative 7/2 into a 1. We will do that by multiplying that entire row 4 by the reciprocal of negative 7/2, which is negative 2/7. So our row 4 will equal negative 2/7 times our old row 4. Our first row stays the same, 1, 1, 1, 1, 4. Our second row stays the same, 0, 1, negative 2, negative 1, 0. Our third row stays the same, 0, 0, 1, 1/2, 1. And negative 2/7 times 0 stays 0. Negative 2/7 times 0 stays 0. Negative 2/7 times 0 stays 0. Negative 2/7 times negative 7/2 creates the 1 that we want. And negative 2/7 times 0 is 0. This is our resulting matrix. We can see that we have our 1s on our diagonal and our 0s below. So this is in row echelon form. Okay, so this is our resulting row echelon form matrix. And now we're going to use back substitution to solve our system. So we're going to look at our fourth row because remember these columns correspond to W, X, Y, Z, and then on the right of the vertical bar we have our right hand side. So that fourth row corresponds to the equation 0W plus 0X plus 0Y plus 1Z equals 0, or simply Z equals 0. And our third row corresponds to the equation 0W plus 0X plus 1Y plus 1/2 Z equals 1, or Y plus 1/2 Z equals 1. And we will take this and substitute 0 in for Z. So Y plus 1/2 times 0 equals 1, or Y equals 1. So now we know that Z equals 0, Y equals 1. We're halfway to our solution. We need to find W and X. We'll work upwards to our second row, which corresponds to the equation X minus 2Y minus Z equals 0, because we have 0W, which would be in the front of the X, which we don't need to write because it's 0W. And here we will substitute in for Y and Z. We know that Y is 1 and Z is 0. So this becomes X minus 2 equals 0, or X equals 2. And finally, our first row gives us the equation W plus X plus Y plus Z equals 4. We'll substitute in for X, Y, and Z. X is 2, Y is 1, Z is 0. So this becomes W plus 3 equals 4, or W equals 1. So we can write our solution as 1, 2, 1, 0 in parentheses. Or W equals 1, X equals 2, Y equals 1, Z equals 0.